So welcome back everyone to the 101 Questions of AI. And today we're going to talk about intelligent agents. So I don't know if you've heard of them before, but we are going to explain exactly what they are and their relationship to artificial intelligence. Luca?
Yeah, an artificial intelligence agent is an entity that makes a decision and, let's say, enables a very quick action given an observation. Actually, I did my master thesis on this subject in 2001 when I was in London. So this concept that has been around for long enough. I'm sure you can already understand that this is kind of an obsolete technology. No, I'm joking. It is actually used already in a few applications that we're going to mention later, probably in another episode. But the idea is that there are two main functions in a software agent. The first one is perception. Typically, you could think about a very simple bot that looks at the weather forecasts, see that it's raining, and then takes an action. An action could be to send you a notification. That notification alerts you that you have to bring the umbrella. Okay. And I mean, the interesting thing about software agents is that they need to exhibit some sort of intelligence. Now, I give an example of a one rule software agent, very simple, but what happens if you combine many rules, together? You could essentially take much more complex and much more nuanced decisions. That's my definition of an intelligent agent.
Okay, so essentially, it's able to look at the conditions, and once certain conditions are met, then it will perform a certain task, right? And then
Absolutely.
a way to make that more complex is to add a number of different rules, right? And then a number of different conditions. And so if those different conditions are met, you have then certain rules following through and they're doing different actions.
Yeah, you got it.
Am I understanding? Okay.
100%. And here, I think it's clear to me, and maybe it's better to spell it out. What are the benefits and the disadvantages of intelligent agents with respect to other paradigms, like, for instance, the typical machine learning paradigm? Here we have rules, Michelle, and we have to, enumerate those rules. We need to come up with rules manually. And this is a challenge. It's a problem because, maybe we don't cover, we're humans, and, we're not good at capturing all the possible difference and all the possible nuances of a use case, of a situation. So it's hard. And this is, a big drawback of the intelligent agents paradigm, to create an exhaustive set of rules that will cover all the possible cases.
That's very interesting. So I think in one of the other episodes, you had explained how, is it deep learning, right? So it learns essentially by itself, right? You don't give it any rule, you set it out into the world, right? In a very specific environment. And then it will learn, like, if I do this kind of thing will happen, and I'll take that into account. And eventually you'll be able to predict. That's the difference, right? So that learns by itself. With this one, we are handing it the rules. So if something goes wrong, or if we're not able to account for every scenario or essentially, right, that's where the problem lies. So then why would we still have intelligent agents if we can just do the other one? Is the processing different? Why?
Well, because they're easy to implement, right? They're very easy to implement. It's just an if-then rule. And, for simple tasks in very constrained environments, in very constrained use cases, it could still work. Take, for instance, smart homes. It's a controlled environment. There is only a very few or limited things that can happen in a room. Let's say that you want to control the light. You have a sensor, you capture the light conditions, you measure the amount of light, the amount of photons hitting the sensor, and then you take a decision, which is as simple as switch a light on, switch a light off. You combine then with another rule, which is, look, I'm always at home on a Sunday morning because I'm not working, or in Sunday evening, better. So switch them on when I'm at home, and switch them off when I'm working 9 to 5, Monday to Friday. Does it make sense?
Yes. So the delineation really just is based on what the objective is. There's no delineation regarding like the processing power or like the financial aspect or like any of these other things. It's just based on the task, right? So I would
Yeah.
imagine it's mostly used for like smart appliances, as you were saying.
Exactly. And the benefit is that you don't need any training data. You don't need to collect data beforehand, and you have third advantage a very well defined and controllable decision or action taken when the rule is activating. Okay, there is no ambiguity. All right. While with a machine learning approach, there could be more ambiguity in the
I see.
application of the action. So there are pros and cons. I mean, to be honest, lots of excitement in late 90s, early 2000. It's that enthusiasm. I feel like it faded a little bit away, but still, it's interesting to know that they are there. It's still interesting to know that it's a very inexpensive and affordable solution to solve simple problems.
Yes. Okay. So that was very illuminative, I suppose, is a good word. I hope it was good for everybody and for the viewers. You understood exactly what an intelligent agent is. And now you are more aware that if the light turns on when you go into a room automatically, you're like, aha, I understand why.
Okay, thank you, Michelle.